welcome. Welcome again, and thanks so much. I'm Julie McDonald. I'm with Minnesota's Lake Superior Coastal Program and the Department of Natural Resources. Madison and I are members of the planning team for these climate conversations, along with Lisa DeGuire from City of Superior and Kristen Schmidt from the U.S. Department of Agriculture Forest Service. These conversations happen thanks to collaboration. We began collaborating back in 2015, and our efforts have evolved over the years. Also, my work in regional resilience is supported by the National Oceanic and Atmospheric Administration Office for Coastal Management. And these climate conversations are quarterly, with some events happening online and some in person. We're a really small planning group, and we invite you to participate in planning and implementation of these conversations if you choose. Today, we are excited to dip into data with you and highlight some existing and forthcoming data and resources which may be useful to you or your colleagues. But first, I want to share with you the goals of these climate conversations. Some years ago, our planning team came to an agreement about these overall goals, which has helped us frame our work as we put on these regular climate conversations. I think we've done a decent job over the years of providing programming to help meet these goals. And today, I encourage all of us to strive to consider climate justice in the presentation as we take this in and reflect on the presentations. Maybe consider how climate change is or may impact underserved or marginalized communities, and do so with the lens of justice. Who will be impacted from climate change, and do they or will they have the resources to withstand the impacts and be resilient? How may we use data to help us address inequities as we work toward resilience to climate change? So today, in the spirit of coastal resilience, we're going to dip into data that may be useful in your work. This is a dip and not a deep dive. Today's webinar will feature 4 presenters, each giving separate 15-minute presentations, close to that. We'll hope to have about 10 minutes for a Q&A at the end of the presentations. Please feel free to pose questions in the Q&A function. Chat should be disabled. We hope to cover the questions at the end, or you can certainly reach out to the presenters separately. Today, first, we're going to hear from Kim Channel, a climatologist at the Michigan School for Environment and Sustainability. Kim will share Great Lakes climate data and resources you should know about. After Kim's presentation, we'll hear from Clinton Little, program specialist with the Minnesota Coastal Program and Department of Natural Resources. Clint will discuss some data updates and applications to support coastal community resilience. And finally, we will hear from Brandon Crumwitty and Lara O'Brien. Brandon is a physical scientist and Great Lakes Regional Geospatial Coordinator for NOAA's Office for Coastal Management. Lara is a geospatial analyst, contractor with Linker in support of NOAA's Office for Coastal Management. Brandon and Lara are here to give an overview and updates of NOAA's Coastal Change Analysis Program, or CCAP. So with that, I want to stop sharing and hand it over to Kim to present. Thank you. I'm going to go off camera. Got it, Kim.
All right. Yep. So you can see the right screen, everything. We're all good. Okay,
Yeah.
Great. Thanks, Julie, for that introduction. Like she said, I'm Kim Channel. I'm a climatologist with GLESA. I'm also joined by my little coworker cat, Asher, back there. If any of you can see him. I'm feeling a little under the weather the last couple of days. I have some lingering congestion issues. So if I have trouble enunciating certain words today, I apologize. Bear with me. I'm here to give an overview of some tools, data, and resources that can aid in inform climate resilience efforts. And a lot of what I'll be sharing comes from GLESA. So I'll start with a quick intro to who we are and the role we play in the region, just so that you know who this information is coming from if you're not familiar with us already. So GLESA is, I want to get kind of the acronym soup of this all out of the way first. GLESA is one of the nation's Climate Adaptation Partnership, or CAP teams, which is the new name for the Regional Integrated Sciences and Assessments, or RISA program, if any of you knew our national program under that name before. And that is where our GLISA acronym originally derived from, but because of the network name change, we are no longer using the full acronym, and instead we're just going by GLISA, the Great Lakes CAP team, at least for now. So we're kind of in that awkward limbo of having a name that's clearly meant to be an acronym, but at the moment no longer stands for anything. And I just like to clarify why that is up front and eliminate some confusion there. So the CAP program, though, is a national network funded through the NOAA Climate Program Office. It's comprised of 12 different regional teams whose mission is to help communities build lasting and equitable climate resilience. And contrary to what this map shows, our service area is not just the Great Lakes Basin, but it includes the entire extent of all 8 US states that border a Great Lake and southern portions of Ontario, Canada. And GLISA is housed at the University of Michigan, where I work in the School for Environment and Sustainability, and we have institutional partners at Michigan State University, University of Wisconsin, and College of Menominee Nation. And GLISA works at this intersection between research and service to help bridge the gaps between science and decision-making, and ultimately help practitioners use and understand climate information to better plan for and adapt to climate impacts. So we have a team of both physical and social scientists that work together to research emerging climate issues and synthesize findings for practitioners. We facilitate trainings or collaborative activities to support partners and networks. We also develop usable climate information tailored to practitioner needs. Usually that's done by interpreting existing information like data or models and synthesizing it in a way that is more usable, accessible, and useful than it is in its raw form. And we also develop resources and tools to help apply that information to decision-making. And that's what you'll see a lot of in these slides. So I know this webinar is data focused, but we likely have folks on with a wide array of different backgrounds today. So I'm also going to introduce just a few more kind of general informative resources that could also aid in resilience efforts in the region, just inform them. But also just know that all of these resources and tools are ultimately grounded in data and are based on analyses that GLISA or our partners have done already, so that you don't have to do it yourselves. And all the slides I'm about to jump into have links to the resources they're referring to, and these slides will be shared with everyone after, so you don't have to write it all down or remember each piece if something looks interesting. And I will note briefly that our website was down about an hour ago, and I was frantically emailing our web folks to get it back up. It is back up now. We hope it stays that way, but if it does happen again and you're trying to look any of these up today and they're not working, I apologize. We are on it, and you can always refer back to these slides later, and the links will be available there. It'll take you to all the right places when our website decides to stop throwing a tantrum. So first up, we have a couple of informative educational resources on climate change in the Great Lakes Basin, Great Lakes region, I guess. We have this 2-page fact sheet and a 15-minute presentation that are both essentially Great Lakes Climate Change 101. That's kind of how we like to refer to it. They cover trends, projections, and impacts for a range of variables and sectors, including temperature and precipitation, lake levels, extreme weather, agriculture, tourism and recreation, and much more. So the fact sheet is meant to be just an easy resource to have on hand that covers everything that at a high level in one place. And then the presentation is one we get asked to give fairly often. It's been presented to FEMA, to regional legislators, to water resource managers, even high school students. So it really is meant for everyone. And it's a little more visual and in-depth than the fact sheet, and kind of gives you that overview of what we are seeing in the region, what the impacts are, if you're a little newer to this. And then we also publish the annual climate trends and impacts summary for the Great Lakes Basin every year in partnership with a few other US and Canadian climate service providers. So this is just a really short 6-page document that summarizes the climate trends, events, new research, and activities in the Great Lakes region for the previous year. So we're about to publish the 2022 version probably any day now, sometime in the next couple weeks. And usually this pulls out the main climate and weather stories of the year and talks about how conditions compared to past years. So it might be useful if you just want to keep up on what's happening in the region as a whole. And then I also want to note that if you want even more frequent basin-wide summaries, the Midwestern Regional Climate Center at Purdue publishes quarterly reports for every season. So that was just a few sources of general background information on regional climate trends, projections, and impacts, but now I'll move into data tools that can help you obtain more specific localized information that you might want to use. And first up here, I have GLISA's climatologies. So these are web pages that summarize historical trends in temperature, precipitation, seasonality, and extremes for stations and climate divisions in the Great Lakes region. So on this page, you'd start off on this landing page, and you'll just use either the search bar, or you can kind of click and zoom around directly in the map on what you want to see. The red dots on here are stations, so that will be really localized data. Blue outlines are climate divisions. That'll give you a kind of broader multi-county scale summary. And then the blue wave icons are individual Great Lakes climatologies. And those are actually a newer addition to this tool. And they're a little different because they cover historic trends for lake-based variables like lake levels, ice cover, water temperature, and so on. So if you search for or zoom in like this to click on the dot for example, the Duluth station, you'd be taken to its summary page with information calculated directly from that station's historical data. Here's just a snapshot of what you'd see on that page. It's got time series graphs, summary tables, trend tables, just information to help understand what has already happened in the past for a particular location. And these pages are currently for historical information only, but the division pages will be getting some future projection data added to them soon, some point in the next few months, I believe. But if in the meantime, you need some really basic high-level future projection information, we have some regional maps that might be of interest. These maps are based on model averages of an ensemble developed by Michael Notaro at the University of Wisconsin, developed specifically for the Great Lakes Basin, which makes it more reliable than models that are used in many other tools that are out there that use national or global scale models only, and they don't kind of capture all the physical properties of the Great Lakes that are really important to our regional climate. So there are maps on this webpage depicting projected mid-century changes in variables like annual and seasonal temperature and precipitation, cooling degree days, days over 90 degrees, frost-free season length, heavy precipitation, and more. So often we combine this type of projection information with historic information from stations or divisions just to kind of put everything into context together. And that provides a really nice, succinct picture of what has already happened in the past and what we can anticipate in the future. A lot of times we use this combination of data to put together fact sheets for individual communities that summarize their local trends and projections. Now, neither of these resources actually require you to download data, analyze it, or generate any figures or tables from it yourself. It's already done that for you, but if any of you are really keen to do your own analyses, make your own figures, I know this is a data-focused webinar, so maybe that's actually the case. We are almost ready to launch our now very long overdue Great Lakes Adaptation Data Suite, or GLADS for short, another acronym to throw in there. Right now, all of the external data that we use to create our resources and tools are just spread across the internet in different sources, different formats. You've got to go to the Army Corps website, download a CSV of water level data. You've got to get a NetCDF from University of Wisconsin for climate projection outputs. You've got to get a text file from Coastwatch to get ice cover data. It's just all over the place, and it takes a long time to get it all together and kind of format it to be able to work with it in the first place. So GLADS aims to pull all of that data into one repository and in a similar format to reduce barriers to its use. And all of the data is already available, but until the actual interface for this database is up and running on our website later this year, you can always reach out to us if you need specific data from any of our resources or for a particular location, and we can always share it directly with you in the interim. And next up, we have the CHAMP tool, yet another acronym that stands for Climate Hazard and Mitigation Planning. The CHAMP was developed with a few CAPRISA teams and the Urban Sustainability Directors Network, and it's meant to be a single entry point for regional and county level data on past hazard events and historical and future climate information. And it's intended to support the development of local and regional climate related plans, and was actually designed with FEMA hazard mitigation plans in mind, though that is not its only potential use. So CHAMP provides data visualizations and narrative text customized for any region, state, or county, and these narratives detail climate trends with definitions and citations, so it's easy to just copy and paste text directly into plans if that's of interest. And then last, on the really data heavy front here, is neighborhoods at risk. This is not a GLISA tool, but it is GLISA adjacent. Neighborhoods at risk comes from our great partners at Headwaters Economics. They have tons of other great planning resources if you want to check them out too. But Neighborhoods at Risk is a web-based tool that uses census tract, socioeconomic, and climate data to generate maps, charts, reports, comparisons, and it's all pretty interactive and customizable. So, for example, you could choose to overlay data on populations residing in the 500-year floodplain with data on households living in poverty or people with disabilities or non-English speakers to see where those vulnerabilities overlap geographically across your community, or in other words, what neighborhoods are at greatest risk. This is really useful in vulnerability assessments in particular to make sure you aren't leaving out considerations of vulnerable populations and that you are pursuing planning efforts in an equitable way. So I just mentioned vulnerability assessments, and actually Neighborhoods at Risk has been a key component of a vulnerability assessment process and tool. It's kind of two in one that we've developed with various partners over the past several years. And all of those efforts have evolved into what is now called FloodWise communities. And this is specifically geared towards stormwater systems. So FloodWise is a web-based tool and a guided step-by-step process that walks you through examining vulnerabilities to your stormwater system. It includes tailored weather, climate, and socioeconomic profiles for the communities that use it. And then it culminates into a comprehensive vulnerability assessment for your stormwater system using the answers that you fill out in the tool as you progress. And this is not an open source tool available to anyone to use at any time. It is login protected so that each community working in it gets their own login information to access and save their assessment answers privately. And the tool has undergone many, many rounds of scaling up and improving over the years with communities in the Great Lakes and the Gulf Coast regions. So it's undergoing some updates right now, but it will be available for Great Lakes communities to use again early next year. So if you're interested in this for your community, I would say to just shoot me an email anytime expressing interest, and we'll keep you on our short list to reach out to when it's ready again and see if you're still interested at that time. And then wrapping up here, last on my list is another methodology we get asked about a lot, and that is our scenario planning approach. So this would take a whole 15-minute presentation on its own to explain, but in a nutshell, scenario planning is a method to describe and incorporate uncertainty into decision-making, ultimately to increase preparedness for multiple plausible futures and extremes. So not just based on averages or what has happened in the past. And GLISA has developed kind of our own particular approach to scenario planning over the past decade or so that was originally adapted from our partners at the National Park Service. And in this process, GLISA develops a set of physically plausible climate, weather, or lake level scenarios, and then we have participants build on them in a workshop and discuss the potential actions that they would take in response. And all of GLISA's scenarios are informed by a combination of input from participants, observations and trends from historical data, and guidance from future projections to ensure that the scenarios are physically plausible in the first place. So GLISA has some resources on our website if you'd like to learn more about this particular scenario planning approach, it's just one of many similar approaches out there. One of these resources is a set of sample climate scenarios that are intended to be broadly applicable and adaptable to fit different needs. And the other is a workbook to walk through every step of our scenario planning process, starting with the initial scoping of the workshop to choosing scenarios all the way up through the specific workshop exercises for participants of the workshop. So these are both available at this link for anyone interested. And that's all I've got. I know that was a lot packed into a really short period of time to wrap your head around, but I hope that by briefly touching on as many tools and resources as I had time for, that I could raise some awareness of what's out there to aid you. And if any are of interest, you can always go back in this presentation. You can look at the slides later and look into any of these in more depth. And please feel free to reach out to me, connect, ask any questions at any time. And yeah, you can check out our website here for other resources if you'd like. And I just want to say thanks again to Julie for inviting me to speak. And thanks so much, everyone on here, just for your time and listening to this. I hope you all have a great rest of your day.
Thank you so much, Kim. Totally appreciate it. Folks can pose questions in the Q&A and we hope to get to them at the end. And now we're going to transition to Clinton Little. So thanks again, Kim, particularly for presenting when you're a little bit under the weather. So thanks. All right, so next up is Clinton Little, and he's going to share his screen shortly. Is it gone, Clint?
I'm sharing. It must be loading.
Okay, sounds good.
And oh, one more button to click. Sorry.
All right, no problem. You see it now. Thank you.
Good afternoon. A second here. I thought I had this.
No worries. It's when
There we
you
go.
share, there's so many options. Yeah.
Yep. I just wanted to hit on some of the data available. Some of this I'm involved in, some of them not, but I want to share it. And I just want to kick off, talk a little bit about LIDAR and the state of Minnesota's involvement in the USGS 3D elevation program. The state of Minnesota through its Minnesota Geospatial Advisory Council and the 3D Geomatics Committee under that council have decided to follow the USGS 3D elevations program nation or statewide because it is a national standard and a standard that comes with a nice carrot, a carrot that helps fund LIDAR in our coastal area, or coastal area, helped fund LIDAR in our coastal area, which is why I got involved, but also statewide. And as you can see the status map here, we've been working on completing the state of Minnesota with most recent collects down in the Minnesota River area this spring. Some of those were hampered by flooding and timing. Basically, in the state of Minnesota, we're looking at collecting LIDAR for the full state with a spring before leaf out collection, so we get a nice bare earth model as part of that LIDAR collect. We also in the Twin Ports area we benefited from being on the front end, so we've got data currently available to us now through the national map, and the national map is hosted by USGS. There's been these collects, even though they're managed by USGS and USGS contracts with vendors for the data collection, they handle all the QA, QC, and then hand the data over to the state. So there's a little bit of a delay. A lot of people expect the state to have this a little faster. But we're partners in this national priority data set. Now, in line with that, these data deliverables will be made available on the national map, and the areas you see in blue here are available now for download. I wanted to hit a little bit on the difference between our first generation LiDAR collect and the second generation LiDAR collect. And referring to this as generational data for the state of Minnesota. This first generation would be what they classify right now as like a quality level 3 under 3DEP, and it probably barely makes that classification. What we're collecting right now statewide, our goal is a statewide quality level 1 and quality level 2 data throughout the state. And if you're familiar with working with digital elevation models, instead of the 1 meter statewide, we're going to be getting a USGS 3DEP deliverable of 1/2 meter digital elevation model with 1 meter and 3 meter options coming. Now, for Minnesotans, what that means to us is right now we have to get the data off the national map, but in the future, as funding and deliverables arrive, MinGeo will be planning to provide a lot of these data resources through a new MinTopo 2. Currently, we serve the existing first generation LiDAR up on an application called MinTopo. And it's getting old and out of date, so it needs some enhancement to meet today's demands and functionality and new data. And then those data sets or derived products that the state creates from the LiDAR will be made available there, and then also in web map services that you can use in ArcMap or ArcPro, depending on what you're using. We do have a Minnesota LiDAR hub. There at that site, we're trying to keep everything up to date, so you can check the status map, learn about the LiDAR plan, and other resources that'll be coming soon. Now, one thing I want to set up here is when we were first part of the first generation of LiDAR in Minnesota, I had a lot of people telling me that was all we needed. We weren't going to need to collect this again. Which was kind of a false idea, a misnomer. Much like aerial photography, LiDAR provides a real unique look at changes over time and gives us a lot of ability to look at change in a 3D model. On this slide here, I have the first generation of topographic LiDAR for Minnesota is highlighted in green. After the 2011 LiDAR was collected, we had the 2012 LiDAR, or 2012 flood, and we were able to work with the state of Minnesota to use some leftover funds to gather a post-flood LiDAR set. And I'll hit on the importance of having those two data collects a little later. But the other thing I wanted to hit on is notice in this Minnesota in the image on the right here from Dan Cracker, you can see on Minnesota Point there is a dozer working on dredge spoil deposits on Minnesota Point to kind of bolster the beach. And with recent lake level increases and storms, that beach has been getting decimated from wave action and water levels. And so if you look at the timeline associated with the storms, you can see in 2019, the Army Corps of Engineers collected both beach topography and bathymetric data, and then have continued that throughout time here for the last couple of years. But in 2020 and 2021, not only are they collecting it in July, but they're collecting it early summer and fall for those 2 years. And those are to look at the pre and post beach nourishment projects. And I'm speculating, but modeling for future work with the Corps on how to stabilize that very active or dynamic shoreline of Minnesota Point. And then you'll see also there's some other work in there and some planned data collection in 2023 here. And moving into that benefit of the pre and post flood LIDAR in 2012, USGS and University of Minnesota Duluth staff had taken those two data sets and worked to do a comparison of erosion and landscape of the landscape around Duluth pre and post flood using soil data and the two LIDAR collections. And on the right, you can see they were able to detect hill slope erosion and deposition, and even erosion in the valleys. We'll zoom in, and what we're looking at here is Mission Creek. The report has really nice summaries highlighting several watersheds in the city of Duluth. I picked Mission Creek because that was one that was really heavily impacted from the 2012 flood and has had a lot of DNR and local attention post-flood. Also, through the USGS recently made available is the USGS landslide inventory for the state of Minnesota. This covers 3 regions in Minnesota so far: the North Shore of Lake Superior, down in the southeast and northwest portions of the state. It's listed as kind of a preliminary data set. It's not comprehensive, but it really starts to show some of the things we're experiencing on the coast related to coastal erosion and just hitting on this area in Sucker Bay near Stony Point. If you've ever woken up on Christmas morning and watched Frozen Surfers on YouTube, this may be where those videos are taken. And this landslide inventory does show where the hillslide erosion is happening, but also where deposition is occurring in riverine areas. On Lake Superior, most of those deposition areas are gobbled up by the coastal processes and moved downshore. One of the reasons why these derivative projects are useful to us in coastal management is we are working with ARDC and the North Shore Management Board on a North Shore erosion mapping tool. This application is up currently, which will show erosion potential, but right now we haven't come up with erosion susceptibility layers, and this landslide inventory could be very influential in showing the need for erosion susceptibility mapping along our coast. And part of that coastal erosion hazard map, we've been using the USGS DSAS tool to come up with erosion rates along the shoreline of Lake Superior. We have on the left-hand side the current erosion rate line data that basically just specifies if an area has an erosion rate over 1 foot per year. With the DSAS model, you can kind of see these red transects. We're getting an idea how deep that erosion is happening and at what rate. That data is currently being reviewed, and hopefully we should see that coming online in a online viewer in the future. So the main thing that I've been working on recently is building off from NOAA's U.S. Great Lakes hardened shoreline classification from 2019. This was a very useful data, and you can see it on the shoreline on the map on the right, it's kind of that bright blue. We've been using that in our shoreline erosion mapping to date as kind of a baseline. But one of the things that I noticed in using the data is it is the shoreline, and it'll specify if there is hardened shoreline in that area. But with imagery being higher resolution, I was noticing that just the complexity of our shoreland structures in response to coastal erosion are. And this is an area just outside of the, it's on city of Duluth, kind of right along the lake walk. And they have several tiers of riprap walls and kind of a greened up infrastructure on, or they greened the hardened shoreline a little bit with some bushes I can show a little bit later. But I wanted to try to, we wanted to, the coastal program, we wanted to try to catch that that type of complexity in our coastal hazards and the types of responses to those coastal hazards and how they're being engineered. We're using the Minnesota DNR's public waters permitting system to help validate our data. And then later on, the line work that I'm creating will tie to that MPARS permitting system. And so internally we can validate that line work through a bit of finagling with data. And I'm currently working with the data stewards related to that. The other thing that I'm doing is I'm leveraging existing county and city high resolution imagery. Most of the imagery we have available to us in the DNR, the resolution wouldn't support the type of mapping I'm doing. And so the oldest imagery I have available to me right now is 2019. So most of these shoreline structures I can digitize from 2019, but I'm also using our coastal oblique inventory to help validate that that data. And so if I have a permit in place and I have an oblique image that shows that that the structure was there in 2022, I've been kind of digitizing a line in there to mark that with a plan to update the delineation of that structure in the future. Let's see if I was thinking if I had one more tip about that. But eventually this will be a really nice resource to add to our coastal erosion mapper and add it to some other resources too. And so with that really quick dip into some of the coastal data available. And thanks.
Awesome. Thank you so much, Clint. I'm sure people will have a lot of questions for you or definitely want to follow up with you later. I'm going to just let it go right now. I'm going to step off camera and we welcome Brandon and Lara. Thank you.
All right, thanks everybody. And I am just pulling up the screen and just want to make sure everybody can see our screen before we present.
Looks like it's still loading. There it is. Got it. Thanks.
All right. Thank you, everybody. Yeah, so today, Laura and I are going to provide a presentation on NOAA's Coastal Change Analysis Program, or CCAP, kind of explaining where we've been, where we are, and where we are headed. So for those folks that may not be familiar with CCAP, the Coastal Change Analysis Program, CCAP is an authoritative source for land cover data in the United States. We are part of the Federal Geographic Data Committee's NGDA or National Geospatial Data Asset when it comes to land cover data for the nation. We coordinate very closely with the U.S. Geological Survey and other federal agencies as part of the Multi-Resolution Land Cover Consortium, or MRLC. And CCAP data has been directly incorporated into the National Land Cover database since its inception. So if you're familiar working with NLCD land cover data, we are that coastal expression that's ingested and incorporated into NLCD. And so, as I said, we have been providing this data now for a few decades. And most of our historical data has been derived from Landsat imagery, 30-meter spatial resolution. And of course, we try to update that every 5 years. And so right now, we are actually making a little bit of a transition, and we'll be covering that here in a little bit. But really for the Great Lakes region, we were fortunate enough to get an update provided in 2016, and of course, working on our 2021 update year, which will be a transition year. And so we're going to talk about what we've done historically, but then of course that future context as well. And yeah, just wanting to touch on, regional products, as that we refer to them on Digital Coast, are those 30-meter products. We've got data going back as far as 1975 for some portions of the Great Lakes, including Minnesota and Wisconsin and Michigan on Lake Superior. And again, we have that up to 2016 at 30-meter spatial resolution for that same geography as well as the rest of the Great Lakes region. And then, of course, what we're moving towards is a high resolution 1-meter product. Historically, this has been pretty expensive to produce, but what we like to say is, providing what we're seeing in the advancements in computer technologies, we are able to make this at a much more affordable price point than what we have in the past. And then, of course, fast, cheap, good, pick two, and we always try to pick one out of those two. And so we're really working to make a great product that people can leverage. So if we look at that past context and again, this regional geography, it has typically been a 30-meter Landsat imagery-based product. Again, part of that new National Geospatial Data Asset. And it is, as I said, that coastal expression of the Great Lakes. In the Great Lakes region, we have 1975, 85, 92, 96, 2001, 6, 11, and 16. And so we have been very fortunate. Some of those older years were actually funded through the Great Lakes Restoration Initiative, just to see the historical context of landscape change in the Great Lakes region. And of course, 2021 is our year in which we will be doing this crossover from the moderate resolution into the higher resolution products that are currently being developed. And so just to show it on screen here is the 30-meter land cover data set and the different categories that we map to in CCAP from 2016 for the Great Lakes Basin. And so what's really interesting here, and I'll bring up the laser pointer, we can see a lot more of the natural land cover settings here in the northern portion of the basin. Of course, as we work further south, the shades of gray associated with urban development, and of course, the shades of brown here associated with agricultural development in the basin. And so again, we can look at these types of things temporally over time. And here's just one example from Chicago showing what that land cover looked like in 1975 and again in 2016. And of course, what's really interesting in looking at this example is you can see that urban sprawl associated with the Chicago and its suburbs to the north here, as well as to the south. But again, even the increase in the density of the development side of things with the core of Chicago here along Lake Michigan shoreline. And so with this, I'm going to turn it over to Laura to provide an update on what we're currently working on presently.
All right, thank you. And as Brandon just mentioned, this brings us to the present and the current development of new high resolution 1-meter land cover data. Next. Thanks. And this new high resolution data can support all of the many applications that the standard 30-meter products can, with the added advantage of giving more regional applications greater precision and accuracy, even if resampled to a coarser resolution. Next. And the higher resolution data also has more detail, actually 900 times that of the 30-meter data. And this information can be used to help support applications and decision-making at the local and site level, which was not previously possible with the regional land cover data. And so you can see the difference in detail in this example from an emergent wetland area shown in both the 30 and 1-meter resolutions. Next. And that increased level of detail is also evident in this example from a more developed area. So with improved impervious surface and urban area mapping, these new high resolution data sets can be used to support better flood risk assessment, stormwater management, community planning and development, and much more. Next. And the spatial detail is also useful in rural areas as well. And you can see with the 1-meter data sets that it captures far more of the roads and urban, rural neighborhoods compared to the 30-meter data. Next. And in places like wetlands and coastal ecosystems, many environmental changes such as erosion occur on a much smaller scale than can be reliably seen at the 30-meter resolution. So more detailed natural area and wetland mapping could be used to improve applications such as conservation or restoration site planning, nature-based solutions, habitat assessments, and carbon accounting. Next. So what will the national rollout of the 1 meter land cover data look like? For the initial phase, or phase 1, the data products will include impervious, canopy, and water products for the contiguous United States. And these are going to be released actually starting at the end of this month and early August. Products for the entire state of Alaska, including snow and ice, will be released August, September, and updates to the Pacific and Caribbean's previous high-resolution data are scheduled to be released in September. And note that this release will also include updates to the high-resolution CCAP webpage on NOAA's Digital Coast, and some of the supporting documentation included as well. Next. And the phase 1 land cover geographies will include all of the areas shown in dark blue, which have been funded through the Bipartisan Infrastructure Law and the Great Lakes Restoration Initiative. And unfortunately, NOAA does not have the funding to produce these products everywhere. However, we are able to offer buy-up options with significant discounts for the remaining areas of the coastal states shown in light blue if there is partner interest. And actually just an exciting update, due to the high level of partner interest in Wisconsin, we were able to exercise an existing task order option to fund the development of these phase 1 products for the entire state of Wisconsin. And this was also possible due to a small amount of remaining bipartisan infrastructure law money as well. There are also areas that are being mapped by others, shown in gray, and we are coordinating with these agencies and organizations, including the Chesapeake Bay Program and Conservancy and the state of Vermont, that have produced or are producing data sets that are similar to ours. And so we are looking to incorporate these products into our own product line in the long term. And we're also coordinating our efforts with the EPA, with the US Forest Service and American Forests, and others who also have interest in national products like CCAP. And then there's also a blue outline that's might be kind of faint, but that is the regional CCAP mapping boundary where we've developed our 30-meter data historically. And it's just included here to show that the coverage extents are not exactly the same, as the high resolution mapping includes full counties and not partial like the regional coverage. All right, next. And so here are the private sector partners that are working with, including our primary contractor, Ecopia. And these products are derived from 15 to 30 centimeter imagery using deep learning and AI. And so these partners include NV5, which is doing the update mapping in the Caribbean and Pacific. There's Woolpert, Tetra Tech, and Dewberry, our prime contractors working with Ecopia in Alaska and the contiguous United States. And as you can see, the one big challenge, the key challenge, has been just the sheer scale of the production. So even though we are leveraging private industry capacity, NOAA eyes and feedback are still required to ensure product quality. So the development has been almost double the standard geography in about 20% of our standard timeline. All right, next. So what does this data look like? So here's an example from Detroit, Michigan. Next. And this is the example of the impervious map for that same area. And we're actually producing two versions of the impervious data. So this is the 1 meter raster impervious layer. And this is just a single category of impervious. Next. And then we're also producing a vector data set that includes 4 different categories of impervious feature types. Next. And this includes buildings, roads, railroads, and just a generic pavement category. And here you can also see the minimum mapping unit, or the smallest feature size that you can expect to be mapped. And the vector data that you see here is actually licensed for internal NOAA use only and will not be served to the public. However, it can be used and viewed through our tools and applications, just not downloaded. But we do also offer a buy-up option for vector data sets that include more detailed categories like sidewalks, center lines, driveways, bike lanes, etc. And this is data that can be really helpful for states, municipalities, DOTs, and others. And this can be acquired at a discounted price through Ecopia. All right, next. And another example is from Charleston County, South Carolina. Next. And you can see the canopy data for that area. Next. And then this is the minimum mapping unit that was used. All right, next. And the last example is from Charleston, South Carolina as well. Next. And here you can see the water data for that layer. All right, next. And the minimum mapping unit. And of key note here is that many of these ponds that you see are actually not included in the most current US Fish and Wildlife Service National Wetland Inventory, or NWI data, or in the National Hydrography data, or the NHD. And that's because they actually just didn't exist when that previous mapping was done, as there's been a huge amount of development in this area. Next. And so that brings us to the future and what our goals are for continued high resolution land cover data production and development. So as great as we think these impervious, canopy, and water mapping products are, it's not CCAP's end vision or end goal. So for phase 2, these initial products will be taken and updated with additional land cover data classifications. So up to 20 total, including up to 9 wetland categories. So in the short term, we are working in locations where we've had partners, had partners that have helped fund this data development. And you can see that Tampa, Florida is actually available now. And this work has also been funded by the EPA and the National Marine Fisheries Services for the purpose of exploring the integration of CCAP into the National Wetland Inventory updates. In the midterm, we will be working in locations where we have some existing but older high resolution land cover products in order to normalize the past and current mapping methods into an integrated time series so that you can actually start doing change analysis over time. And then in the longer term, so phase 3 and beyond, our ultimate goal is to have full land cover data available in all coastal states and update this data every 4 to 6 years for use in both land cover and land cover change analyses. All right, next. So here are the approximately 20 land cover categories that we map as part of CCAP. And you can note that these are essentially the same categories that we have always mapped, and they're very similar to the National Land Cover Dataset Scheme. And the wetlands classes also relate to a simplified version of the National Wetland Inventory, which works well in potentially leveraging our map in the National Wetland Inventory updates or vice versa. Next. And so to provide an example of what to expect with this full CCAP high resolution mapping, here's a couple of examples from the Tampa, Florida area with the additional CCAP classes added. Next. And so you can see the increased level of detail in the impervious and canopy features, especially. So looking at the buildings, the driveways, roads, sidewalks, and it even captures the impervious under the canopy. So it just brings a large amount of detail and information to use. And next, So I'll turn it over to Brandon to talk about some of the applications and tools of this data.
Sure, thanks, Laura. So I know we've just got a few minutes left here, so I'll try to expedite through these slides, but just wanted to capture, some of the applications where we see this high resolution data being leveraged from everything from improving flood modeling and forecasting. I'm not going to go through this whole list of text here, but just, getting back to Kim's comment about FloodWise, definitely bringing in new data sets like this to help improve the modeling when it comes to weather and forecast modeling. But then also too, looking at stormwater management, things that we hadn't thought about with our regional cover that come to mind now are things like broadband infrastructure mapping, or identifying urban heat island effects and tree equity issues as it relates to this higher resolution data as well. Like I said, improving flood modeling and forecasting guidance, with the higher resolution, and here's an example of 4 feet of sea level rise in Tampa, Florida. We could, of course, generate a similar case here in the Great Lakes with a 1 foot to 2 foot increase in lake levels. But, understanding which neighborhoods and even specifically which houses may be impacted by flooding. And so that greater level of detail allows us to become more precise in the mapping of our coastal areas. The other thing is too, helping to look at things like reducing flood insurance rates. Instead of an entire community being assessed one given rates, you could start to look at the greater detail in inundation, identifying open space preservation and helping to reduce the average flood insurance premiums by doing some of that open space mapping with this higher resolution data as well. And again, as I pointed out, tree equity, here's one example where they're looking at it through the environmental justice lens in the communities in Connecticut. And again, that urban heat island effect and issues in the built out environments, and looking at opportunities where communities can further improve their canopy within the community. Of course, we have tools available that look at this land cover data. The Land Cover Atlas is a current tool that is available on Digital Coast. And this is just one example for Douglas County, looking at the change in wetland cover from 1975 to 2016. And note that it's just a small decrease here. But we can look at things like forest cover as well, and the other land cover classes present within the current regional land cover data sets. Another tool that we wanted to make sure that people were aware of, and one of the questions I get often asked is, where did Open Inspect go? And Open Inspect didn't actually go anywhere. It just changed its name, but is currently available. So those folks that work with water quality, of course, land cover data is one of the important data sets in that water quality assessment. And Open Inspect is now QInspect. It is now a plugin within the QGIS software package, available for direct download within QGIS. And what's nice is we have created new tutorials and guidance documents in how to use the new QGIS with QInspect and plugged in. And this certainly, as highlighted in other presentations here, would be a presentation unto itself to learn more about QInspect moving forward. And so with that, I know we've only got, it looks like a couple more minutes, but just wanted to provide our contact information. Check out the Digital Coast, and the QR code here actually highlights not only our high resolution CCAP work that's been funded through Great Lakes Restoration Initiative, but all of our other Great Lakes Restoration Initiative projects as well that the Office for Coastal Management has been helping with. So with that, I will go ahead and stop sharing.
All right, thank you so much, everyone. We don't have much time here for much else at all, but we did get one question in the chat that Kim answered, and everyone has shared their presentations. So I just want to encourage people to sign up to receive notifications of the events and check out the archive videos on the Minnesota Sea Grant website. I don't see any other questions at the moment. Anyone else? I can't even see what is being shown. I'm going to stop sharing so I can get back to this. All right. I want to thank everyone. Our participants can't speak up, so I'm just going to speak up and say thank you very much. It was just a dip into what is very obviously a huge world of data, and I know Clinton Little and Minnesota's coastal program is generally available for Minnesota's coastal communities to give assistance if people have questions. And I'm guessing that all the other presenters here would be willing to respond to an email. You shared your contact information. So thank you. Madison or anyone else want to chime in with anything before we sign off for the day? Let's see. Okay. All right. That's a wrap then for our July climate conversation. Huge thanks to all the presenters for today. And hopefully people will be reaching out to you and we can use this information to have more resilient communities.